One. This is Gerald Clark with Seven Planet Broadcasting, and today I've got a very exciting guest from London, Roland Michel Tremblay. How did I do on that pronunciation? Okay. And I stumbled across Roland while I was preparing my third series in a gravity series program. And it turns out what we're going to talk about today goes way beyond just gravity, but it was the entree into this program. I had read a book several years ago called The Final Theory, and many of you have probably heard me discuss it. I didn't go into detail real heavy because I was talking about ancient astronaut theory, so I didn't really feel that was the place. But as an engineer, this is very much near and dear to my heart, is knowing the true physical laws of what surrounds us, what operates life. And Roland turns out to have read not only the same book, The Final Theory by Mark McCutcheon, but he also is writing his own book called New Age Physics. Is that correct?
Yes.
New Age Physics. Is that the right title? Okay.
And
he's written many. Yeah, he's written many screenplays, books. He's got 6 or 7 books now published in French, and you're just a prolific writer. And I could tell by interacting with you that you got a really good handle on what's going on, probably as much so as anybody I've ever discussed this expansion theory with. So today, Roland and I are going to kind of go through some of the questions that I posed for him. And I did this intentionally. I didn't re-review the book when I posed the questions because they were the old questions I had when I read the book the first time. And Roland came back and just blasted me with so much information. I felt like I wanted to get his perspective directly. So Roland, say hey to everybody. And anything I left out, not introducing you, tell them what you're all about.
Yeah, so just to say that The Final Theory is the book by Mark McCutcheon, and it's about the atomic expansion theory, and my book is New Age Physics, a theory of everything, which builds upon it. So it encompasses more what you would say the New Age or spiritual people and aliens are talking about when it comes to different dimensions, which Mark doesn't touch. So Mark is pure physics and how he can re-explain everything through the expansion of the atoms. And me, I take that further.
Yeah, that's actually where I guess you and I ended up kind of in the same camp. Is when I got a degree in electrical engineering and studied all the standard physics stuff, it had Newton and Einstein stuck in my head. By the time I got out of college, you get out of college unless you're working in that space, you don't get to play with those models much anymore, right? So I had kind of tucked those away until I saw this book, and I was a big fan of Richard Feynman and Kip Thorne, and not so much Stephen Hawking, even though I thought he was interesting. But I followed The Future of Space-Time, their book that they wrote out of Caltech about what they were going to do to try to pin down what gravity is. So I've always been kind of a hobbyist in this, but I don't think I've been as interested in it or spent as much time on it as you have. So I formulated some questions for you, and first of all, before we go into that, do you want to talk about just real briefly where we leave off with Newton and Einstein and why we went off to talking about a final theory, why there was a need for a new discussion of a new theory?
Well,
you don't have to. Go ahead.
Clearly, Einstein thought there was something wrong with Newton if he came up with his own general theory of relativity, and that now replaced Newton. But the problem with Einstein today is that to make his equations work and his theory works, we had to invent dark energy, dark matter, the Big Bang theory, from which it all came from, and gravitons or gravitational waves and all these things. And none of them are likely, and none of them, basically none of his equations or theories are actually matching with observations that we look at in the universe. So clearly there's something wrong with Einstein, and that is very clear. And with Newton, that we still use in our space programs today, if it was perfect, we wouldn't have to have countless course calculations or corrections whenever we send something in space. So there is a problem there too. Also with Newton, there's a major problem, is that it defies the laws of conservation of energy. Where is this attracting force coming from? Does it emanate from matter?
Right.
You know, it's still unidentified, and none of it basically. Mark McCutcheon discussed all this in his book. He debunks the entire Newton's and the entire Einstein, and then he presents his theory. So at the end, they're all models of the universe that describe our physics, and they're all models that kind of work to a certain extent. And you can actually achieve these models just through observation and general data and statistics, and actually come up with equations in time that works. But at the end of the day, we don't perhaps have the real explanation that is required to explain everything. And when you consider expansion theory, from the fact that just the atom can be expanding all the time and the electrons as well, you can explain all of physics. Mark McCutcheon has rewritten the entire physics in his book, The Final Theory. And then at the end of the day, you look at these models and you see which one describes everything best, and then you realize that you decide which one is the right one. For example, with Mark McCutcheon, we can finally calculate for the first time through equations the gravitational force of the Newton, the big G, you know, the universal things. This has never been done from calculations. It has always only been done from observation. Then, so from that point of view, you can see that there is a proof here. And there's so many proofs after proofs when you read the books that you can see, oh, that's why. Oh. And then suddenly all of these weird explanations from quantum mechanics goes. We don't have to explain the impossible, like quantum entanglement and things like that. So it all makes sense now.
You know, I was thinking about the sequence in which I asked you the questions. It now seems to make more sense to me to start by talking about what the four fundamental forces are for people, because most people don't know, and then starting from the inside at the atomic level from this expansion theory, and then working their way out. What do you think of that? So let me give my real quick understanding to people about what the four forces are, and then maybe you can launch into the atomic expansion theory, because we've mentioned it now, but people don't know what that is. Okay, you and I do, but they don't. Okay, so number one, when I was exposed to physics, I was taught there's four fundamental forces. There's the strong and weak nuclear force, electromagnetism, and gravity. And somehow the physicists had made these four distinct forces that somehow arose from the Big Bang theory, and that they were trying to unify and figure out how they all came from the same source, the grand unification theory, right? Well, with that said, we ended up with models that are still being taught in college that are 100 years old that truly do not fit, like Roland said, with what we actually see. They're just models of what the effect is, but they don't explain what it is, right? So why don't you talk about the expansion theory that you and I both got exposed to by Mark McCutcheon, and then let's start at the atomic level and do the strong, the weak, electricity and magnetism, and we'll end with gravity, because it's really the hardest one once you get into the orbits and the visualizations and the geometry to figure that out. Does that sound fair?
Yes, you know, there's one thing about these four fundamental forces of nature is that they were very arbitrarily designed in the beginning. You know, they were kind of four things that needed to be explained, but you know, the course for unifying these four forces into one thing, it seems like they are disparate things. They are disconnected, if you want. What is important is to explain what they are, you know, and then you can, through expansion theory, explain each of these things just by the fact that the atoms are expanding and the electrons as well. And so that's the unifying part of it, if you want, in expansion theory. So for gravity, for example, at the moment we've got this mostly Newton, where it's a force attracting at a distance. And then if you take Einstein, it's the whole universe is like a rubber sheet. And then, you know, if a big object is in the middle, then the smaller objects will actually kind of roll around like
I actually just did a simulation. I didn't give you the second one. A guy from a university had taken a big piece of lycra spandex and put it on a spherical hoop, put a weight in the middle, and was rolling balls of different sizes around on it, like the gravity well from Einstein, as a visual aid. It was helpful, but it's just a visual aid, and it's not the truth. But keep going.
Well, they pretty much say this is the truth, because space-time and space-time mass energy is one concept in Einstein. They all link together. And this is where the time is relative. Now, none of this exists now in expansion theory. But there is another way to explain gravity. It is the fact that objects come closer together, and also objects fall onto the earth when you drop them. And this can be seen instead as a changing distance between two expanding objects. So the reason why objects attract each other is because the distance between them is reducing as they expand. And why an object is actually falling onto the Earth is because the Earth is expanding, like to catch up with the object. The object is actually free floating where you drop it. It's not falling to the Earth. The Earth comes up and catches up with it. This is the elevator effect of Einstein, which inspired expansion theory by Mark McCutcheon. So this is basically what gravity is. It's just the fact that everything's expanding. The atom, every atom is expanding at the same universal expansion rate. And so everything expands at the same time proportionally, so we don't see it. We cannot see this expansion. But it explains what we see if we imagine the concept behind it, that basically everything's expanding all the time, and the geometry of this expansion explains all the orbits and explains also gravity, the fact that objects will come closer together.
A couple of numbers came to my mind while you were talking about this. This is for our scientific listeners, I guess. That atomic expansion rate that turned out to be fixed x sub a was something like 7.7 times 10 to the negative 7 meters per second square. Is that right? Or 10 to the 7 meters per second square?
I don't know the number exactly, but it sounds about right.
It was different than the 9.8 meters per second squared that Newton used, right? So it was very close to that. Even
no, but that's the expansion rate of the atom. You know, when you look at the Earth has got that many atoms in it, and then overall for the Earth, you know, it expands, you know, proportionally at 9.8 meters per second. This is still true because this is based on observation.
Right.
So this is an acceleration. So everything expands in an acceleration.
So you take the constant acceleration of expansion x sub a, apply it to the geometry, and you end up with gravity. Essentially, is what you're saying.
Yes.
What the effect is that we feel of gravity is the expansion of anything coming close. So this is hard for people to wrap their head on. You want to do the beach ball expansion concept for people so they can get a visual of that, or do you want me to do it? The two beach balls on top of each other.
Cool. Go ahead.
Okay. This one actually helped me a lot. For humans standing on the Earth, from expansion theory, if everything's expanding, this relative inability to see things expanding around you creeps you out, okay? It messes with your head. Let me put it on a gallery view here. So if you viewed the Earth as a beach ball that could be inflated, and you were a small beach ball standing on top of this, you know, and making contact without worrying about the closing distance thing, as the big beach ball was being inflated, the small beach ball is being inflated at the same rate, but because of force equals pressure times area, the force you're going to feel underneath you is the Earth pressing you up from that big beach ball. And that, to me, really helped me with the elevator experiment from Einstein, is to visualize this in terms of expansion, right? Yeah. That helped me. But then you took that little beach ball off some distance away where you started from geosynchronous orbit. If you just drop it, it was like, okay, why is it falling? And then this is where your Newton head gets stuck, right?
Yes.
We'll talk about all that.
It's falling because the Earth is expanding towards it at a much higher rate than the ball itself is expanding.
Now, this part also got me really crazy, is when you actually calculate how fast I think it's like every 19 minutes, it doubles in size, something like that.
Everything doubles in size every 19 minutes.
That is a mind blower.
Although the expansion is an acceleration, at the end you still end up with the Earth getting bigger by 4.9 meters per second, and that's constant every second. You reestablish the geometry of expansion every moment by moment, every second, and then you look at the geometry then, and then you can see what's going to happen. That's why geosynchronous orbit, where the satellite doesn't appear to be moving, is that every moment you recalculate exactly where everything is, and it stays where it is. But that satellite is still going extremely fast. It's going fast enough to be on an orbit around the Earth, and it matches the rotation of the Earth. But the idea that that's why it stays where it is. But in fact, there's no difference between a geosynchronous orbit or any orbit. It's something that is moving away from us in a spiraling orbit. And then so when you can't see that the expansion, the space between the satellite and the Earth still remains the same, because the orbit behind the scenes, the gut viewpoint, is always enlarging, like the solar system.
And the satellite's expanding too. So it's just, or whatever, yeah.
Yes. So that explains why if an aircraft carrier is dropped from the sky and a small marble will arrive at the same time on the ground, because this is impossible in Newton. So when the Earth is expanding towards it, of course, it will arrive at the same time. But even...
I'm sorry. A good way to think about that is that aircraft carrier and that marble are floating in free space, just like the Earth.
Yeah.
And that the fact that they're expanding and they're the little beach ball and the big beach ball is going to come up to meet them eventually. This is hard to grasp, but that's what's really, I believe, is the reason this is called the final theory.
Now, the problem with Newton is that you calculate the gravity based on the mass of the objects and from the center of these objects. In expansion theory, you calculate the gravity from surface to surface of the objects. And also the fact that the planet, if it was a styrofoam planet, would make no difference because the geometry of expansion will still be the same. So all our course corrections in space with Newton probably is that we don't know exactly the mass of any objects. And the gravity doesn't depend on the mass of the object. So that's kind of a proof that Newton was wrong. And we encounter similar problems with Einstein. So as you can see now, we have the chance to have real equations, the equations of Mark McCutcheon, that will precisely give us the perfect, we won't need any course corrections anymore. And we also know about the real gravity that we can expect wherever we go, because at the moment, it's really hit and miss. When we went on the moon and we thought the gravity would be 1/4 of the Earth, because the moon is 1/4 the size of the Earth, we got it completely wrong. It's a miracle that it actually landed because it was not, it was 1/6 the gravity.
Yeah,
but what people don't realize is that on the other side of the moon, the gravity will also be different. It will be 5/6 of the gravity, you see? So, I mean, no, it will be 3/4 of the gravity of the Earth.
Yeah,
so
let me touch on this one. This one I must have missed during the first book is the difference in gravity as a function of the side which is expanding if it's being exposed to another body. So the opposite side of the moon is what Roland's saying will be expanding at a different rate because the near side is also being impinged upon. I don't explain the near side, why the gravity facing the sun is different. Is it because of the sun's expansion?
Because it's the Earth-Moon formation made the moon be more dense on our side than it is on the other side. Or I think it's the opposite or whatever. But anyway, we go from the center of mass. And the center of mass is actually near us. So I guess, yeah. So near us, it's more dense and it's less dense on the other side. And since expansion goes from the center of mass, it starts at 1/4 perhaps of the moon up to the other side.
Right.
So, and then, although you could only calculate that when you are on the moon, and you cannot actually calculate that gravity from space because the moon still expands like a sphere in every direction.
Right.
You know, this density distribution and the center of mass makes it that it will be a different type of gravity on the other side. So I think I heard the Chinese are going to the other side of the moon soon.
I heard
that too. If you don't pay attention to this, they probably will crash. And then Americans will, I don't know, laugh about it. I don't know.
It'll be interesting to see what the dark side of the moon has to offer. Maybe they'll stay in low orbit first before they get too close and realize, hey, this is expanding different than we thought. So,
well, they've got to be careful because otherwise.
Well, I feel like we jumped past the 4 fundamental forces, went right to gravity because that's the one that really gets us. Let's talk about the strong nuclear force from an expanding electron standpoint and how changing charges could lead to what we call valence shells, and also it leads to chemical bonds that you pointed out very clearly. You want to talk about that real quick? So
yeah,
start from the strong and go to the weak.
The strong nuclear force is simply what is keeping the atoms from flying apart. Exactly. That's the big reason that they came up with some sort of strong nuclear force that, again, has no explanation, defies the laws of conservation of energy, and, you know, never really identified or anything. But if you look at the expansion of an atom, which is made of neutrons, protons, and the nucleus, and the orbiting electrons, in Mark McCutcheon, actually, the electrons are not orbiting; they are bouncing off the nucleus of the atom.
I saw that.
So it's just that they are just expanding against each other, And as they expand from each other and they exchange electrons around them, or the electrons are bouncing, then there is no reason why it will actually fly apart. So we resolve that issue by the fact that they are all expanding against each other, they are pushing each other, and then the electrons are bouncing on top of that, and then the electrons would actually bounce from one atom to another, and then to another atom, and it will actually be bounded to form molecules. So that's basically how the strong nuclear force is explained in quantum in atomic expansion theory. So that's not a big mystery. Well, now we have identified what it is. There's no big force of nature there that is unknown, you know. So it's just that.
Well, this is one area where I think you're gonna discover things that may be different than somebody who only ascribes to the scientific principles. This is where I guess you reach the point where you keep asking why. Okay, if you ask yourself, why is an atom expanding? Why is this the case? What is the catalyst for that? We don't answer that with this theory, right? Because this is where it goes to something much bigger, some fundamental reason why matter would act this way. And in my opinion, that is encapsulated with what I would call the creator of all laws of matter in establishing the holographic universe, in essence. And that's a real scientific leap, which is not science, but
I will say that you're right when it comes to explain why the atoms are expanding or why the electrons are expanding. That can explain every phenomenon there are in physics. We have to go into philosophy or religion, you know, or spirituality. You know, they are the fields of society that will explain why this, why that. You know,
right.
But, you know, it's very simple. If you get a computer and you do a virtual reality, you would have these objects on the screen. You will have, and they're all made of electrons. At the moment, it's all just electrons. But if you are programming the computer to actually form into protons and neutrons, because in expansion theory, everything is made of electrons. It's the only fundamental particle in nature. There may be neutrinos, but until it's really proven, you know, there are only electrons.
You're not a fan of the particle zoo that's being developed over at CERN.
That people need to understand that all particles are just made of electrons. So you can smash them in any size you want and give them names that you want. But particles that exist only for a millisecond, is that a particle? You only want particles that can actually be stable in nature. Now, even the neutron is not that stable. It will decay, and beta decay, which is the nuclear radiation thing. It will decay into a proton, a neutron, a neutrino, and actually and a proton. So that's a neutron, beta decay. So it's not very stable, and then it becomes more stable into a proton. But you can smash that proton and have two new particles there because they're all made of electrons. So
well, let's leave our atom smasher behind for a second. And now I think we kind of have a concept of small spherical protons, neutrons, electrons, and possibly neutrinos that are exchanging charge. Like you said, you got to have somebody that's taking care of the transfer.
There is no charge. There are no more charges in atomic expansion theory. There's no positive or negative charge. Everything's explained just by the expansion and the depletion.
I guess groupings of electrons, because they're always going to seek to dissipate their imbalance in polarity, if you will, from an ion back to a molecule, right? That's just what they do. So
that's actually one of the four fundamental force of nature. It's that electromagnetism, and so that's very interesting because in atomic expansion theory, electrons become clusters together. And then all clusters of electrons becomes light, radiant forms of energy, and then heat. And then if they actually are more distant, they're not in clusters, they are clouds. They are clouds of electrons. These are magnetic fields, and they are, magnetic fields are basically clouds of electrons. And then the movement of them from where there is a depletion of electrons and where there's a surplus of electrons, seeking balance, that creates all these movements. But even then, Mark doesn't really talk about orbits of these particles like electrons, but I do, in my book, because I think that That's a very interesting thing. It all obeys the same laws, whatever the scale. And, we know that electrons are extremely small compared with atoms. So, and, atoms are concrete objects that forms everything that exists around us. But electrons are much more, if you want, intangible. But I think they are more tangible than we think.
Can you relate the weak nuclear force to how chemical bonds take place? Because oftentimes you see in chemical equations, there's a balancing of various equations that essentially have ions joining to make molecules. So do you want to talk about that, or do you think that's clear enough relative to this theory?
Well, it's very simple. I mean, there are a certain number of electrons that will actually go around an atom. And then if another atom comes by with as one less electrons, then one electron will actually bounce between the nuclei of these two atoms.
Right,
and that's
right.
a bond. And
Right.
so, and in certain conditions, then, hydrogen will become something else, or, another material will become something else. It's very interesting. This is all very instant. That's very interesting. But so, I have my theory is that it's the same with electrons. I think that they probably are. They have a nucleus, and they have orbiting particles. For me, it orbits, it doesn't bounce. And I think that this is how they can actually join into clusters. This is how they can form a proton or a neutron. They also have particles exchanged between them that are called neutrinos that actually can, because there's no charge. There's no positive or negative charges anymore. So it's got to all be the natural orbit effect of atomic expansion theory. And that explains all the atoms as well as the planets and stars and everything. So,
this is probably not fair to you, but you're such a smart guy, I can ask you. In the concept of a electron versus a photon, how would you distinguish one, or how does one form together to create the other? In particular, electrons creating what we call a photon.
Well,
something that emits light.
Photons no longer exist in atomic expansion theory. A photon of light are just clusters of electrons. So little clusters together of electrons, and then they actually form, these little particles. So that's why. So that's how I can explain it from the point of view of expansion theory, which is, it doesn't make much difference.
How would it emanate energy that we perceive as light?
Well, energy in atomic expansion theory is just the movement of electrons. It's just the expansion of electrons and the movement in either clouds or clusters. And for Mark McCutcheon, there is no longer any kind of energy in the universe. It's matter. All of it.
Yeah, explain that a little bit, because this really caught me. It's like, wow, so light emanating from the sun, we call it all kind of things, a solar wind with all these ionized particles traveling. And all of a sudden, based on this expansion theory, what you just said is the entire universe is really an electric universe. And I've seen several authors essentially come to that conclusion. And in addition to that, because of that, if an electron is considered matter, then it's all matter. It's just in different forms.
Yes,
am I right?
That's very interesting. Yes, it is true as well. And it doesn't make much difference whether, you feel that energy is like photons and intangible, or if you think actually it's made of matter and electron clusters or electron clouds. It doesn't change anything. It's just a different way to see it or to explain it. But
do you have an explanation why there's a sinusoidal behavior of these clusters of electrons that are representing the electromagnetic spectrum in all its various forms? Why would it use this transmission medium? Is it because it's most efficient? I mean, what do you think?
Well, if you actually light up a light bulb, then there's a reaction there. You actually free electrons from the atomic world, the subatomic world, and then they start expanding at extremely high rates. And then they are pushing against each other, and then this is why light goes across the whole solar system and in its expansion. They are all electromagnetic spectrum. The only difference, first of all, you've got to understand that in atomic expansion theory, there are two different parts of the electromagnetic spectrum. They are totally different. The first part, has got nothing to do with the second part.
Oh, really? Okay.
So one is actually more about electron clouds, and the other one is about electron clusters. So if we think about visible light, and I think before that is it infrared, and then going higher into ultraviolet and all this until you reach the highest. The only difference is that there are more clusters passing by per second, the intensity, or there are larger clusters or smaller clusters. So that's the only difference to explain the different electromagnetic spectrums when it comes to the part where there are the clusters of electrons.
Mm.
I've got a very interesting things about that in my book because
I'll bet you do. I'll bet you do.
that probably would be too complicated to get on here, but it's fascinating stuff. And this is the frequencies that people are talking about that comes from that, the different frequencies. And it's true, the frequencies, how many clusters of electrons there are, and you know how large they are. So that makes a difference.
I know where this is going, but I want to save that for a little while. So I'm going to do something that we can't probably visualize very well here, but I know there's 2 experiments and I read them, okay? But for people that want to know, okay, if all matter's expanding and I'm expanding, the planet's expanding, and it's all doing it at the same rate, I can't detect it. How can I prove this to myself? And there's a couple of experiments that have been done involving a spring and a rubber band. Do you want to talk about those real quick? Just and give any insight to the merit of the pros and cons of this experiment, if you have them, because I think it's very, very profound.
I haven't read them again recently. I'm going to try to, from memory, to try to.
Oh, okay. Well, just do
no,
it.
I can probably still say a few things. Is that you know, objects are free floating. So if you've got 2 balls with an elastic band and then you drop them, you know, the ball is there and the other ball is there, and you drop them. Well, logically, according to Newton, they should go poof, exactly the same. They should stay the same because they are attracted to the planet at the same time. But what happened is that the elastic band contracts because they are in free fall. They are free floating. They might as well be on a satellite, the International Space Station, because they actually contract as if there was no gravity at all.
Mm-hmm,
and then they get to the floor. Now, for the spring experiment, that's I can't remember exactly, but
it had to do with pulling the spring in such a way that one end ended up with the tines of the spring being farther apart than the other because of the same concept you're talking about. If gravity was actually pulling it down, it would stay distended, but no, it collapses back just like the elastic band. I think it's the same experiment.
Perhaps I will have to read it again. It's been a while.
Actually, yours, I think is a bit better visual for me. I didn't realize there were 2 balls. I just had it in my mind that one ball was extended from an elastic band. You cut this, and then the band would shorten. But if gravity was pulling on both the same, that wouldn't be the case.
There is something as well that we didn't actually thought it was proof, but it's a little drop of water. When it drops from a branch, it immediately becomes a ball, but it could be explained by surface tension. But at the same time, it shows anyway that it's kind of in free fall. It becomes a little ball like if it was on the International Space Station. And lots of water falling, you know, usually can drop into as if they were free floating. So if you can check this. And it's very interesting that insects can walk on ceilings and on walls because the expansion of the walls and expansion of the ceiling downward is enough gravity for them to be able to stay there. Because
That's amazing, isn't it? Isn't that amazing?
This is just the beginning. There are so many things we can explain.
Oh, I know.
And once this theory is recognized and lots of people are starting to work on it, there will be an industrial revolution. It could save the planet. So I think people should really pay attention, you know, consider these new alternatives instead of, you know, criticizing before they even read the book as in the past, because there is a lot of potential here.
Well, I'm going to save 3 things for after our break. Faster than light communications, a space elevator, and the last one I'm going to make a surprise. Actually, no, I'll tell it now. You were leading up onto density changes in matter that lead to what we consider a dimension. And we're going to come back after the break and we'll talk a little bit about your concept of the density changes that lead to what we call dimensional realities, because I think this is an area we both have a lot of interest. So you want to take a little nature break and catch up, and we'll come back and get back together and finish this up?
Yes, no problem.
Sound good. Okay, I'll put you on pause here and we'll come right back.
Okay.
Okay, you're on pause right now. So we're just talking on the break that maybe we didn't spend enough time with the verification experiment. I caught him off guard with that one. I didn't list it in his thing. So he's had and the way his brain works, he went off on the break and he probably reviewed the whole thing, and now he's ready to talk about that a little bit more. So this is a simple experiment for those that are just joining us back to validate that all matter is expanding, and that what we perceive as gravity as an attractive force is actually just the opposite. It's a pressure we feel with our feet against the earth that's pushing us up. And it's interesting because when I was in structure work, I wanted to tell you this. We had a concept of relating the human body to the gravity field, and we would use lines and planes and blah, blah, blah to visualize this. Before and after we would do the work with the people. And essentially, it was softening up their fascia so that at all the joints and places that the bones would naturally help them align in the gravity field if they knew how to, it's not a posturing thing, it was basically understanding what's level, because your eyes using the horizon can establish what a horizontal plane is, the proprioceptors back in your occipits then sense where the center of gravity is in your pelvis and adjust you in 3D space to be what you think is vertical, right? And so we would capture this on a grid chart and so on and so forth. And we played with the effect of what gravity does to the human body and how to get the human body to be at most ease with that field. But nobody knew what gravity was, okay? Just like scientists, we didn't know what it was. But pragmatically, we were doing everything we could to have the best experience with it, even though it was nefarious, okay? So why don't you talk about a little bit about this experiment to validate that matter is expanding and that gravity is not pulling down, but actually is this expansion force.
Pushing you up.
Yeah,
so
exactly.
Yeah, so there's nothing actually that emanates from the planet to actually attract you to the planet. And that's why people all around the world can actually be standing on the planet. The planet is expanding, pushing on everybody to actually keep them on the planet. And it's the same with the atmosphere. Atmosphere is not going into space because it's being pushed in all directions by the Earth expansion. And so it's very different now when you look at the rain and when you look at the snow, because it stays where it is and the expansion of the planet reaches with it. So that's it's a different way to see the whole reality. And it's very interesting because once you are really into it, you read the book, you understand it because you read it 2 or 3 times, you actually you really see the reality differently. And in a way, it makes more sense that way than it used to with Newton. The spring experiment, for example, Einstein at the elevator experiment said the principle of equivalence is that if you are in a space elevator going in space with no Earth inside, that is actually accelerating upward, it should have been no difference with all the Newton gravity on Earth. But there is a difference, and that's what Mark McCutcheon mentioned in his article about the spring, is that if a spring is actually being hanged at the top of the elevator, if there is a Newton gravity underneath it, the spring should be completely, it should be completely stretched. Because there is 2 forces, the hanging force and then the gravity downwards. But if it's an elevator in space, what you would see instead is that the spring goes up and it's stretched more at the top and then less stretched when it comes to the bottom. So there is no principle of equivalence. It's not the same thing. And that proves as well that Newton's gravity cannot be true. There is no force that brings a spring down, otherwise it will be completely stretched. And he proves this as well by doing it horizontally and then vertically, and it's the same thing. So you can see that there is no gravity there that brings the springs down. So that basically, it's a very difficult proof. But Mark McCutcheon says this is the best proof of expansion theory. It's on my website, themarginal.com, if people want to see it and read the article. So it's the spring experiment, gravitational field. So that's very interesting. But it comes to the fact that this is what gave Mark the idea that the space elevator experiment is not the same as Newton. There are lots of things you can do there with the lights that goes down, and as long as it is matter, and it doesn't matter because it's matter, it's not energy. So it acts exactly like matter would act when it passed through near a sun, the gravitational field, the gravitational lens effect or whatever. It's actually moving. The path moves, but it's going too fast to become an orbit, so it just curves. So things are not exactly where we think they are in the universe because of that. So all of this is explained in the book, The Final Theory. So everything has been rewritten, and explained. Interesting.
I will have to say that even as an engineer with a graduate degree in electrical engineering, it took thought experiments of looking at these pictures, trying the hat on, running it through a simulation in my mind before many of the, I guess you could call them the vignettes or boundary conditions are just explained relative to gravity. And I thought Mark did a pretty great job at covering almost all of those, where he, it's a classic sales technique. If you've got an opposition to an idea, you got to raise what the opposition ideas are and then address them, right? Well, he did that very, very well. And some of it is, he does it in a lay way, but some of it's even for an engineer or a scientist, it's going to take you time to play with it a little bit, because it doesn't, and you've been programmed with Newton and Einstein all through your path. And those are the models that you've played with for so long. So they're in your neural network and they're burned in there, and it takes a while to overcome those.
It would be easier for someone who doesn't know anything about physics and maths to understand expansion theory, the book, because it was written for lay people.
Mm-hmm.
So people who know nothing about physics and maths. And it goes from the beginning, explains everything, and then it builds on what it's explained before. And so at the end of the day, it's an entire physics in itself. So you don't need any of the previous physics to understand it. The problem begins when you've got too much Newton and Einstein in your head, and then you have to change everything. Space-time is gone. Space-time, mass energy is gone. That alone is a big jump, and just to understand orbits in atomic expansion theory, when you have all these orbits of Newton and forces acting at a distance and everything, it's a big shift. But the book is understandable to anyone. That's what is interesting. And the math section and derivations of his equations, they are optional parts, as clearly stated, so they can jump over this.
Right.
So that's what is the brilliance. Usually engineers, I don't want to, they can't write, I'm afraid. They can't, every things I'm reading on the internet, it's like, poof, you can't understand anything they're saying. But Mark is different on that point.
That is the difference. And I know this for a fact. If I were to communicate with my audience as an electrical engineer and stay with electrical engineering speak, I wouldn't have an audience. Okay, that is one of the things you have to do to be able to bridge your specialty to be able to communicate with people. And I think you do it very well, by the way. I can't believe, I was looking at your education. You've got a master's in, talk about your education, how it is you somehow have grappled with atomic expansion theory. You weren't trained as an engineer or scientist. Maybe that's why you get it so readily. I don't know.
Well, I did lots of science in college, math, physics, and.
Okay. We'll talk about that. So you got programmed some too.
But I don't have a degree. I was university degrees. I did philosophy and French literature. That's what my master's is in. But people are autodidact. I don't know if that word exists in English, but I've been reading about science all my life. And so at the end of the day, you get to know everything there is, Perhaps I would get lost if someone asked me specific questions about quantum mechanics, yeah. But, I have the whole expansion theory in my mind, and I've read everything I could find about all these concepts to make sure I understood what was and how it is now, and so I can answer people. But so far, I'm okay. People don't trip me too much on questions, unless they are trying to. But yeah, I don't have a background in physics, but this said, I know a lot because I read a lot. I've read all these books by.
Well, coming from me, I'm telling you what, you have a better grasp on this theory than probably only second to the author. I mean, you have really dived deeply into this. And every time I've asked you a question, you've not only had an answer, but you've had a plethora of data to go with it. So kudos to you for actually being that.
Oh yes, I've been working with Mark McCutcheon. I've been working with Mark McCutcheon for a very long time. It's more than 10 years now.
Oh, is that right? Yeah.
All my articles that I've written about expansion theory, he has reviewed and edited. So it's as good as if, it's not contradicting anything that he said.
So you're in very close contact with Mark. And by the way, just for the audience that's listening, his book, The Final Theory, I would like to have Mark and Roland together on an interview to discuss, and if I can get Mark on separately, then I'm going to try to do that. But Roland was very amenable to get him at short notice to come on and talk about this. So
the only articles that exist on the theories are the ones I've written. it's very virtually well non-known, which is very strange because it's so revolutionary.
Don't you find that absolutely bizarre? And listen, I read this book at least 7 years ago, I think. I can't remember how long ago I read it, but it was at least 7 years ago. When did it first get published? You remember?
2001.
Oh yeah, it was about then. It was about
And it was a
2002.
success. It was a bestseller on Amazon, you know.
Yeah, that's how I came across it.
But then nobody talked about it, and it was everywhere online. There were trolls, and they were, oh my God, how can you say anything negative about Einstein and Newton? And they will destroy it before even reading the book. And kind of succeeded, you know. It was nonstop, you know. Mark had to basically retire from the internet because of these trolls. People are very, it's protected, the standard theory.
I know. Listen, I want to give you an example. I went back to UCSD to finish up my PhD in electrical engineering. I guess it was in 2009, something like that. And I got a job working there while I was working at that because I had left industry. And of course, you take a huge salary cut when you do something like that. And I was working on getting a National Institute of Health funding for research into brainwave changes, and as a function of getting children who had degenerative neuromuscular development disorders and things like that, and basically had genetic problems and had trouble learning. So much so that you needed an intercessionary method, a new method to try. And one of those that I learned from this exposure to this mind modulator that I bought was you could, through music and various entrainment methods, these children were very susceptible to that. Could we get them into a state where they could learn, right? And monitor their brain waves and see where that is, and maybe we can just take them there and open up some channels, right? Anyway, I brought this up in a meeting, and everybody was excited about getting this NIH money. And the people that I was working with, these are electrical engineers. Some of them were from India. The idea of talking about this, they completely shut it down. The idea of messing with energy in the human body, they didn't want to do that. It was absolutely, you think academia is a place where you can talk openly about any subject? Not at all. Just like you said, unless you're kowtowing and getting research money that's going in and you're working toward that tenure, you do anything to disrupt the boat and where the money's coming from, you're out.
You know, and the peer process where you can only get something published in any kind of significant literature is destroying science, because nothing new can come out because nobody would approve it. So, you know, we've got a significant problem in science, which is, you know, unrelated to new theories, but it's worth noting that something's got to change. Otherwise, you know, new theories will be completely closed from ever entering the mind of people. And there's no way in. It's extraordinary, you know, except perhaps like yours.
Especially when you're getting to something as sophisticated as physics. I mean, this is not something that the lay population takes on themselves. They usually defer to somebody else, you know, somebody, the science guy, or Stephen Hawking, or, you know, there's these priests of physics that interpret everything and then give it to the lay population. So it's not common that people like you and I are having a conversation about something like this. It's very unusual, right?
Yes.
And that's sad that you're the only one that's written these kind of articles on this incredibly encompassing theory that I truly think is the grand unification theory. That physics still is getting funded to go fine, but it's sitting right here in a book, has been out for years, right? Is that how you feel about it?
Yes, and I'm pretty sure this is how Mark feels as well. I've actually did an interview with him. It's also on my website, themarginal.com. So if people want to read it, because it was something we had not done before. And then suddenly, you know, we get an idea of what he thinks and how he view all this, because he had the success on one side. Lots of people agreed with him and it was great. And then there were the trolls who did everything to destroy it. So, and you know, he said it's a sidestep affair, but I think he's got some distance from this now. And, you know, so it's dynamics of science, you know, and I think everybody's aware of this, you know, in science and physics anyway. And maybe it will change one day, I don't know. But, you know, you just need a big proof like the Arthur Eddington, I think, that proved Einstein, and by, you know, fiddling his images of where a planet was supposed to be in space, and they declare overnight and on the headline newspapers that it was like the proof that we were waiting for Einstein. You know, an eureka moment like that, something that is undeniable. And we're still pursuing this. But, you know, the biggest proof that the expansion theory is real is that the pioneer anomaly. People.
I was just going to say the Pioneer experiment. Talk about that, because that, by the way, Pioneer 10 and 11 and the Voyagers go right into the heart of my research relative to Dr. Harrington out of the Naval Observatory, who was looking for the perturber of Neptune and Uranus. Okay, this is the Planet X search. It's
Yeah,
all the way back to 1789 or so. Okay, so it was very interesting in the discussions about the perturbations and relative to where the Pioneer comes in. So talk about what happened with Pioneer. This is very interesting, by the way.
Well, the Pioneer probes, the spacecraft, there are two of them. They are exiting the solar system right now, and they were accelerating after a whole bunch of slingshot effects, bypassing near other planets. So it was a very big surprise when they realized that they were actually decelerating. And so there was, for many years, like I think over decades, where they tried to explain why are they decelerating while they're exiting the solar system. It doesn't make any sense. So they came up with lots of kind of ideas about, heat or leaks or whatever, and none of them really stands to scrutiny when you look at it. It's still a mystery. The only way to explain it is that in expansion theory, when all the planets and the suns are expanding, all the orbits of the planets are expanding as well, and spirals, although we don't see that. So it looks like it's all the same, but effectively the solar system is expanding. And only now that the Pioneer probes are exiting the solar systems, we can see that, because before that, they were part of these orbits and they were expanding with the orbits, but now no longer. So the solar system is catching up with them in the slow expansion. So that's why they are decelerating. And so that is a big proof of expansion theory, atomic expansion theory, to make the distinction with the inflation theory, which is also, according to atomic expansion theory, a theory that is probably incorrect. So that's a proof. That's another. There are many proofs. When you read the book, you can see every page is like a proof, because suddenly another mystery in physics is.
That's how it affected me when I didn't even get through the first chapter of the final theory when I first picked up the book. That first chapter on gravity, the conservation of energy, and the violation of the work function, all those things in that first chapter. I knew right then that everything I was taught in college may have been a model of what we were looking at, but it wasn't the truth.
The first chapter of the book is available online for free, on Mark McCutcheon's website, which is thefinaltheory.com, where basically it's just taking Newton and Einstein and saying everything that is wrong with his theory. That alone is priceless, because
exactly.
the whole website of Mark McCutcheon doesn't say anything about the theory. It's all about what is wrong with the science at the moment and all the answers what we need to answer in physics to clear all these problems. So that alone, if anyone is looking for a theory of everything, they would have to have an answer to every point mentioned in the first chapter. The second chapter is where he starts talking about expansion of the atom and how it resolves all the issues of Newton and Einstein. So chapter 2 is where it really begins. And chapter 3, I think, is the orbits, the explanation of the orbits and expansion theory, which is very interesting. Because, I didn't think of orbits until I reached that chapter. I say, how is that explaining all the orbits? And it's not easy, but you read all that, and it's understandable for anyone, even if no scientific background, and it's revolutionary.
Right. Well, I think what really caught me up on the orbits was, I might have mentioned to you, I was involved in a satellite program at one point where my job was to build the telemetry and command unit modem for Globalstar. Okay, so this was a digital commanding unit that would run out of a PC. They'd put them in their little control centers, and then basically they'd see so many birds, depending on where they were located, over the horizon. And it turned out we could see 12 of the 54. There were 48 main and some spares. But the algorithm was that, when you were trying to communicate with one, you could see 12 of them at a time, and they're all moving in low Earth orbit, right? So they're not stationary. And so the idea of dealing with Doppler shifts and all those kind of things that we had to deal with in jumping frequency to anticipate where it was and then track it. I know about Doppler now, and I wanted you to talk about the redshift proof that that the universe was expanding, if you want to, or we can go into the faster than light, the density changes.
No, that's important. That's very important.
Because you want to do that? Okay, go ahead.
Yeah, because the Big Bang theory, doesn't really have any support in observation when you look at. There doesn't seem to be a central point where everything exploded from and became the universe we see. So the inflation theory that goes with it, where the universe is expanding and eventually might squeeze back or expands to infinity, doesn't really have any support. When you observe the sky, you can see that everything is clusters in galaxies that are relatively static, strangely enough. And that plays with Einstein's big blunder where, oh yeah, there is a constant in the universe, there's not, and then there is, and according to the new theory that came out. So the redshift, all of this came from one problem. It was the redshift idea that the Doppler effect in sound is the same with light, which is absolutely totally different things. Sound is like compressed pockets of molecules of air, and then light is clusters of electrons in space. So they made a mistake of thinking that the red shift in lights means that an object is expanding ever further away at a very high speed, or is coming towards us, or so they think that it relates to how far they are, which is not true either. So so the only way to know exactly if something is that far is perhaps looking at the quasars. There are other ways or methods, but the red light shift is completely wrong, because light, if you just go it through in the laboratory through plastic, or you can see that it would go to red shift. So when it crosses the sky and it goes across gas, clouds, and also how do you call it? Anything that there is in space in between, it will affect the light. So you would see a redshift. It doesn't mean anything about speed or location or direction of it that this is going. So the idea that we need dark energy, to explain these theories of Einstein, or dark matter, where 99% of the matter in the universe would be missing, that all these problems you don't need if you are in atomic expansion theory, because you explain all the orbits in a different way.
Right.
And, all of this becomes superfluous. And so that's extremely important, because there's a huge side of science at the moment that depends on this and research this dark matter and dark energy, and it's absolutely, not required. And when you look at the sky, there's no support for it either. Everything is kind of relatively static. So
I wanted to add,
all this was just for Einstein. It was just to make the equations of Einstein still work. Now, as soon as it proves that Einstein was incorrect. So at that point, we should have said, this theory is not working, we need another one. But instead, they've invented dark energy, they invented dark matter, and then they bring these kind of crazy ideas that doesn't make any sense.
Well, that's how the Microsoft operating system works. One lump of warts on top of warts to fix whatever was going before, right? And our scientific theory ends up like that. And sometimes you got to stop the iterative process working from what you've got. You've got to do a new paradigm shift when the evidence no longer supports what you're doing. Like if you're creating proportionality constants to make yourself famous, hiding stuff in them, like Planck constant, Newton's constant, the big G, the little g, and now Einstein has his own proportionality constant. This is ridiculous. Okay,
this is very interesting,
when you're hiding stuff, in proportionality constants.
You just said it. It's a proportional kind of constant. It's just for comparisons purposes. Equations is what it does. You just compare things with other things, and then you can come to a point where, by comparing this with that, you can see that if this is like that, this will be like that, through observation alone. So
Exactly.
This is not a true description of the world or a model of the universe that explains everything. This is why atomic expansion theory is so good. We finally have an explanation for everything that is behind. It's the expansion of matter that drives everything around.
Right. Well, like you said, when you ask the word the why, and not, okay, this is what it's doing, and we see the effect of it, and we're modeling it, but it never answers the question why, or what the truth is behind the concept of law of conservation of energy. And let's just talk about that real quick. It's a zero-sum game. We got this much energy in the box, and it can move around in various forms, but it's always the same amount of energy, whether it's in material form, whether it's electrons, whatever it is. And we both agree on that, right?
Yes.
Okay. So from that standpoint, you can't invent energy that comes from nowhere that creates this magical pulling force that's coming from matter. You go, okay, what's doing that? And then you have to go, okay, is it the electric universe, something striking the matter that's causing this reaction that we call gravity? And all these things have to go through your mind before you finally realize there are different models, and some of them hang together a lot better than other ones.
The electric universe idea as a theory of everything is very interesting, and I've not investigated that as much as I would have liked, but it is totally different than atomic expansion theory. You know,
I don't think they're mutually exclusive.
No, exactly. The gravity is explained by just the expansion of matter and the geometry of it, but there are other interactions with you know, electrical fields or magnetic fields, perhaps across stars, you know, and that doesn't affect gravity at all, but you know, have other effects, you know, that could probably, there may be kind of roads, if you want, of magnetic fields that can be used either for communications or transport, right, which we come to faster than light communication.
Exactly. Well, you read my mind. All the way from London. Go for it.
Yes, quantum entanglement is a very interesting phenomenon, as you might know, of two little particles or subatomic particles that are sent from the same location, seems to be remaining connected in some way over large distances. And then if you change the polarization of one, for example, it will automatically affect the other one, no matter how far they are. And that seems to be defying the speed of light. Now, it's a very strange phenomenon in quantum mechanics that's got no kind of answer to it. But Mark McCutcheon in atomic expansion theory explains it by simply these particles, when they are created like light, if you want, it's clusters of electrons. And what we don't see is that they are still connected by a long span of those electrons. And no matter how far they go into space, they're still connected with a huge span of these very compressed little electrons that are being produced at the same time. So when you affect one, like the Newton Cattles game, where you've got the little bearing balls, and you drop one, and then poof, the last one at the end goes up. Or if you put two, poof, two at the other end goes up. Newton Cattle. So this is a way to communicate faster than light. So you have those two particles, you hit one, and then suddenly at the other end you instantly get it. You know, the propagation of these balls can go faster than light if it goes across a long distance. Because, you know, it's this propagation, you hit one and they all each other, and then you get to the other hand. So that's a way to communicate faster than light. There is another way to see it, this, and my way, is that things expand. So when you're from the same source, you've got two subatomic particles or light or whatever that goes out at that place, they are just expanding from that same place that they are. So if you've got two particles, they are still touching each other, but they're just expanding. So if you hit one, it hits the other one automatically, no matter how far they are. And, you know, light, for example, coming from the sun, could just be expanding across the whole universe. Mark doesn't see it that way, I must say. But it could just be expanding, and then until it gets out of the universe. So, you know, it's still here, but it's expanding. So you've got the edge here. So
I actually tend to agree with that. I have to tell you, not to interrupt too much, but as we're talking about light, I actually had lots of experience with light at a company called Lightpoint Communications, where we did communications through the air using infrared light, okay? And because of that, all these issues you were talking about with the scattering of light, we had to experience, well, if you've got this size particle and you're transmitting light at this wavelength, then you're going to have a collision. You're going to have Rayleigh or me scattering that's going to lose some of the energy that doesn't get to your receiver, okay? So we played a lot with this kind of stuff, and the most mysterious part to me is with expansion theory, these electrons are pushing against each other, but at the same time, I can take a laser, align it coming from both directions at the same frequency. One's a transmit, one's a receive. They're absolutely overlapped, and there's no interaction whatsoever. Yeah, people can take two flashlights and cross them like this and see there's no interaction. But the idea that two laser beams are aligned together with a transmit and a receive, and that you can transmit and receive on that same wavelength of light, that was fascinating to me, how that property of light could be real. But it is real.
So if we had a colony on Mars, and we had the laser light that was going to Mars and was reflected back to us, and it was always on, we could find a way to send a signal through that light that would be instant instead of taking, is it 13 minutes or 8 minutes? It's 13.
Well, This is that quantum entanglement thing you were talking about, using the polarization of the light. And I think this is very much where faster than light communications is going.
So instead of taking a few minutes, it's probably less than 4 or something, I don't know, from the Earth to Mars, depending on where it is. You know, it could be 8 minutes.
I know the Earth to the Sun's about 8 minutes.
Yeah, exactly. So, but depending if Mars is on the other side of the Sun, you know, the way is that you could, if you can find a way to send a signal here at that end that is received automatically, instantly on the other side. So it's like an embedded signals within the light. And you know, we know aliens don't communicate that way because they seem to be doing it telepathically, but some of them seems to be using these kind of signals anyway, kind of way of. So if there is an internet anyway for civilizations that are more advanced than us, they will probably use a system like that that goes faster than light than us anyway. So when you look at SETI and the way they are listening to signals, well, there is another way. There are maybe patterns within the light itself, which would be
well. This is how
communication instead of taking light years to get to where it is.
Right.
So they've got to pay attention to that. I contacted them, but they didn't have any faith in any of this.
Well, with free space optics, what we were doing is basically on-off keying of a 1 or a 0 right across the diode. Okay, so it was either lasing, it was on, or a 0, it was off, and they were able to achieve 2.5 gigabits per second, just on-off keying with a VCSEL laser diode, okay? Now you do that bidirectionally, you got 5 gigabits of data. That's unbelievable. And now if you want more, add another lambda, right? Do dense wavelength division multiplexing and start stacking lambdas in there, and all of a sudden, there is no limit. It's whatever light will support.
Yes, exactly. What is interesting is that this method of communication would only need, you know, the light of the sun and the light of the moon.
Exactly. Modulate that.
We won't need bandwidth anymore. So all the problem of bandwidth and airwaves and things will go overnight because it will and we don't even need satellites either, you know.
Exactly.
But there's something very important in atomic special theory that people need to know, because with Einstein suddenly off the picture, we can go faster than the speed of light. That's the first problem. The only problem with the faster of light was Einstein's space-time concept, which no longer exists now. So there is no reason why we cannot go faster than the speed of light.
Well, you know, I found out, not to interrupt you, on this particular point, I always had it in my mind that light was a constant. That's how physics treated it, right? Well, all of a sudden, here we are sending light through a fiber and realizing the density matters that light's going through, because it might travel slower than the speed of light, and it surely does. So density and the medium with which light's going through affects its speed.
And I don't think, exactly. In my book, I do, and Mark McCutcheon says that too, is that the speed of light is not necessarily constant. We have no proof, really. There is no experiment that we've done on Earth that could be significant enough to say without doubt that the speed of light is constant. And, you know, in my own theory, light is just like gravity, because it's matter, it's expanding, but it's expanding at a much higher rate than atoms, so because it's electrons. And so we have to calculate the speed of light as if it was, you know, a changing distance between two expanding particles.
And you have to take into account the medium too, so, right?
Yes, exactly, because when light goes through a block of plastic, you know, it slows down. And when it gets out of the plastic, it resumes at exact same speed that it was when it ended.
Isn't that amazing? That is amazing. Hey, did you see that experiment recently? They sent light through I don't remember what the material was, but I think it was a rare earth metal, yttrium or something like that. I can't remember, but it was done at one of the science labs in, I want to say Stanford or MIT. And what they noticed was that when they sent the light through this material, light exhibited a very new property they hadn't seen before, where they had very unique clusters that took on geometries of these electrons forming together to make it through this material, which they'd never seen before. I thought that was absolutely fascinating. Only a nerd would get that, but it's like,
that's
wow.
Interesting, yeah.
Yeah, I saw on the internet. I just saw it last week, but it's like I still think there are properties of light we don't understand.
Yes. And that's why they always talk about in a vacuum. It's got to be in a vacuum. And as soon as it's not in a vacuum, which, you know, never in a vacuum, then everything goes out the window, you know. So then we have to explain all this. And Mark McCutcheon does that in the book. He talks about this block of plastic where light goes through, you know, and the difference that it makes.
Right.
So it's very interesting.
So we were going to talk about density changes if you're up for it.
Yeah.
Now, first of all, from my standpoint, I use this holographic model to talk about the law of matter and law of time because I haven't found anyone else that's provided us something that talks about the quantum encryption encoding of material to create the atomic forms that we call matter in this depth. Okay, so and this came from the Emerald tablets. I think I might have sent you a copy. It takes a while to get through that too, just like Mark's stuff. Okay, but that being said, I think there's some connection between the law of time, which was claimed to be a infinite vibration over the void of space, according to thought, that I believe is related to the law of matter, and their interaction actually causes these atoms to expand in this holographic model. There had to be a source for causing this, and that's my best guess, okay? But just so you know, but he does use the word space-time multiple times, which was very interesting. And according to the records, if you follow these back, they go back to at least the time of Atlantis, and Alexandria, the Library of Alexandria. And prior to that, according to Thoth himself, it says they were written 35,000 years ago. So the idea that they're talking about parallel dimensions, space-time, and the nature of light in a document like this really tripped me out as a scientist. So.
Well, you've got to be careful because there is always filters. When people receive kind of information from elsewhere, whatever it was, spiritual, alien, or
Oh, yeah, right.
They have to use words that we know, and concepts that we understand. Otherwise, we wouldn't even have any idea what we're talking about.
That's a very good point. Yeah.
And so when it's translated, or whenever they're trying to explain a concept to us, they would use an idea like antimatter. Now, what is antimatter? That's very interesting because in science today, antimatter is nothing weird. It's just normal matter that goes into a different direction than normal matter. Nothing weird there. There was a time when antimatter meant, the reverse of matter, and everything will explode. According to Mark McCutcheon, antimatter will not explode with the contact of normal matter in atomic expansion theory. So, sometimes they talk about something totally different, and you've got to understand exactly what they're talking about. So when they use the term of space-time, well, do they mean something else, Because in atomic expansion theory, time is ticking the same everywhere. Time is no longer relative.
What do you consider the void of space to be? That where matter is not, yes, maybe it's partially infused with electron cloud, maybe it's not. What do you refer to it as? The void, the space between matter that's expanding? What do you call it?
The space, you mean?
Yeah, you just call it space?
Space is just void, Of course, there's no void in space. There's always particles everywhere. But the space in itself cannot be bent. It cannot be twisted. It cannot turn around to create a wormhole, in the atomic expansion theory. Space is just emptiness. And then matter within it just, obeys the geometry of expansion. And then the orbits are expanding and everything in that space. So there's no... space in itself has no longer any kind of tangible kind of materiality that Einstein was talking about in space-time that can be twisted and everything. And time is the same everywhere.
Except from the atomic expansion theory, these particles that are creating the electromagnetic wave or magnetism, those are considered intrusions into the void by small pieces of matter that are...
Yes, it's just matter moving about in space.
It's funny, I got to tell you something funny. In Mexico, when you have dust in the air or you've ground up pepper, okay, in a bowl, it's still polvo. It's pulverized, right? So it's funny to think about this in terms of polvo, right? The electrons are the polvo that are floating around through the void.
Yeah.
It's still considered matter. That's an interesting concept.
But light is matter too, as I said. They're clusters of electrons. So there's only matter in the universe. There are only electrons in the universe. Some people say there's only one particle in the whole universe, and it goes so fast that.
Is electron energy or matter then? It's
Sorry?
both. What you're saying then is electron is energy and matter. It's both.
Yes, exactly. The energy concept's got to be seen now in the context of it's just matter that act differently according to different processes.
Right, right. There was a good explanation talking about melting a block of ice with heat and talking about how the atoms separate and go from its various forms, solid, a liquid, and then to a gas. In terms of explaining this, does that model work for you, or do you like that one?
No, no, this is actually to explain dimensions, which is quite interesting.
Okay, let's go there. Yeah.
Now, if you look at what is the difference between water that is ice or liquid or a gas, it's just the spacing between the molecules.
Mm-hmm.
So if you eat something or put pressure on it, then it will become ice or it will become liquid or it become a gas. So it's just the space between the molecules that changes. Now there is another possibility about to explain the different dimensions is that, and they're always talking about this. They are talking about the fourth dimensional world and the fifth dimensional world, and they're talking also about the fourth density world and the fifth density world. So there you've got an idea that they're talking about density, and it's the same thing as dimension. And dimension means size as well, that people might have missed. So they were really clear that we just didn't make the link. And what is interesting here is that the frequency of matter. What is the frequency of matter? Well, it's just how fast these electrons are spinning, around inside the atom itself and then between the atoms. If that goes faster, these electrons are actually orbiting faster in some way, then the atoms are getting bigger and then the molecules are getting larger as well. It's not just the spacing between the molecules are larger. So we've got a new type of molecule here. And that's what a new dimension is that if it vibrates faster, you get matter that is still physical matter, still a physical world, but we can't see it because light goes through it and we go through it because it's larger. And it's not a gas, but it's very similar. When you see a ghost materializing in front of you, it looks like a gas, but it's not a gas. It's that the molecules are larger and with energy they can perhaps reduce the speed or frequency of their electrons around the atoms, and then they can take form. That's just an example. They say that.
I wanted to hit you with, what do you think some of the catalysts are that humans could be exposed to in terms of light, sound, frequency, that might give them an experience of a dimensional change? Because we were talking about this earlier on a break.
Yes. So if you want to transform water into a liquid or a gas, you would simply eat it or put pressure on it. And so it's slightly different if you're trying to get larger molecules or get these electrons to go faster within the atoms and between the atoms. So the molecules become larger, a different type of molecules that would create perhaps a planet made of different type of molecules that we couldn't see, but would still be here sharing the same space. And I think from what I could see or I came to the conclusion of is that it's all a question of vibrational rate and also, frequency, so how fast they go or down. So the sound could probably do this. Sound or specific frequencies could actually make those electrons go faster or slower and, move you to another dimension. There is also perhaps electromagnetic fields and also light that is already kind of vibrating at that kind of frequencies, because it would be light that goes made of clusters that are larger or more spaced out or whatever, the same as matter. And if you come in contact with this, then your matter would also perhaps become larger molecules and you move to another dimension.
How do you relate this to the individual's ability to change their brainwave state? And the claims are by many gurus and yogis that once they change their frequency, they can travel dimensionally.
No, I must point out first that this is not in Mark McCutcheon's book, The Final Theory. These are my own ideas in the book I'm writing now.
Well, I want you to talk about those ideas relative to your book too, okay?
And so it's very interesting because by thoughts, it seems that thoughts alone can affect, our own processes, which is, true. From any doctor would tell you that getting cured of anything is mostly thought. As long as you believe you'll be cured, often you are. So the placebo effect. But so this yoga is very interesting because if they can affect their own biological kind of systems, because it's all electrical biology systems, then they can probably vibrate at a faster rate. All the electrons are way faster. What happened there is that their density changes. It's the same for UFOs. UFOs, if they are not from our dimension, they are from a higher dimension. So all the molecules are more spaced out. So the density is very light there. So they can float easily as soon as they can change their vibrational rate or their frequency, because they are larger molecules. And you know, it's like everything. If you've got a balloon at the bottom of the water, it will go up, because anything that is less dense than the dense material that it is in, it is pushed up. And if there is helium in the balloon, which helium is a very low density gas, then it goes up the atmosphere. So that's how the spaceships can actually fly very easily up the atmosphere. They are basically pushed up of the atmosphere because the density is so light. So it's all a question of density, but still of physical material. So there's nothing magical about, you know, these other dimensions. It's the same as now, as what we see. But it may look like gas to us in certain points, but it's totally different. It's just that the molecules are larger and probably more spaced out too. So that's why we see that as a gas.
Well, in your mind, you mentioned that two parallel realities could be existing based on different densities in the same location.
Yeah, not just one, not just two. You could have loads. You know, they're saying there are 7 dimensions, there are 14, there are. In fact, you know, if you read Jane Roberts, there are an infinite amount of dimensions. In fact, I'm going to tell you something. I'm going to tell you something interesting here. Flies, they vibrate at 250 hertz, which is 4 times more than us, which is 50 or 60 hertz. When you look at flies, for them the time is different because they've got much more time. They can do 4 times more in the same amount of time that we can. So you try to kill the fly, and it's got plenty of time to move away before you get there. So in fact, we see the fly moving fast forward. A tortoise that actually vibrates at 15 hertz is actually seeing us moving in fast forward. When we look at the tortoise, we think it's moving in slow motion. So if you look at this, a tortoise, a human, and a fly live in 3 different dimensions. But dimensions that we can still see and can still interact with. You know,
you bring up a fascinating point that I want to touch on. You just mentioned 3 different frequencies for these biological beings. In general, do you believe that there's an energy template that has an associated frequency with all matter, just being general? There's an energy template that precedes the creation of all matter.
Well, according to John Roberts, the underlying universe is just an electrical universe. It's just a whole bunch of electrons everywhere, and from that, you know, it's almost only electrical signals that our brains interpret, because what is reality at the end? Our brain gets all these electrical signals and then form the reality. So in my book, you know, we are very much at the center of the universe. We're going back to an egocentric universe because everything is projected out of our brain, the whole entire reality. That's the first type of expansion that I've identified in the 4 types that I've got. And, you know, Mark McCutcheon is the second type of expansion of matter that explains gravity and everything else. And it's very much like a computer. There's no difference. It's like a CPU of a computer creating a virtual reality. But, you know, our brains are basically the same thing. We've just
talk more about how you see it being a virtual reality simulation from a computer. Because there's a movie called 13th Floor. Have you seen it?
Oh, yes. One of my favorite films.
Oh, there you go. Well, so you get it. Yeah. And I see it the same way. By the way, I've written a lot of simulations and done a lot of.
And we can create a virtual reality exactly like in 13th Floor very easily by just reprogramming the computers we already have. Because if we program the computers that we have from the electrons to form into protons and electrons and neutrons and atoms and molecules, then you get a virtual reality that is indistinguishable from reality, because according to atomic expansion theory, everything is made of electrons anyway. So it's just a question of the advancement of, you know, the matter. And then, you know, you can program all this. You program, you know, when you use a computer, you program all the laws of physics you want.
Exactly.
And the speed they're going at, and then you can have different dimensions if you want, if the molecules are larger or not. But so that's one thing. And even in Mark McCutcheon's, in his book, The Final Theory, the way he explains how everything happens in the universe, looking at the distribution of galaxies and matter, it seems like he may very well just have appeared like that one day in that kind of distribution. And then from there, everything seems to have started to expand and then to move around, and with the expansion and the orbits and everything, and form into more complex matter and everything. So even for him, the possibility that we are living in a virtual reality is extremely possible from you know, the atomic expansion theory. And for me, it becomes even more clear if somehow it comes from our mind, just like little computers. It's like a PS4 network where everybody's got their own computer, their brain, and then we're all interconnected psychologically through, or Wi-Fi if you want, through a network where the reality that we built or constructs has got to correlate with everyone else. And so in dreams, you are totally, it's your own independent reality. And it's the same thing. Dreams apparently are also made of molecules, atoms, and everything, according to Jane Roberts. And then that's you call another dimension too. It's just that it's much lighter, the no density to it, and that's why there is no real space. That's what's interesting.
Well, let me ask you this. Now that you've touched on something really trippy, do you feel that you're a energetic avatar having a material experience? And if so, why are you having it? What's the point?
Well, I think, well, there's no proof, first of all, that our reality is really psychological in nature, and that we create each our own reality and we build sensibly the same thing through complete instant communications all the time. This is what Seth says in Jane Roberts, who was, so I'm not so sure, I'm not sure it exists or it's true. But, the reason for it would be probably exactly why we play video games. At the moment, the whole economy is collapsed. The only thing that is still selling like a great deal of money is video games and virtual realities and adventure games and things like that. So it may very well be that we're just experimenting with elaborate simulations of world. And I'm sure you've read this futurologist somewhere in England, some university, who says, the likelihood that we're going to live, that we are living in a virtual reality are so high.
Mm-hmm. There's a lot of scientists that now sign up to that, actually.
Yes, atomic expansion theory fits perfectly with this because it can explain everything.
It absolutely does. And as a matter of fact, I have developed enough simulations and have written enough artificial intelligence programs that I personally think I could create a simulation and set the parameters for a virtual reality experience. But what I'm asking you is, if that's true and you're here having a virtual reality experience, what's it for?
We're here to learn. Well, it seems that
here to learn what?
Well, that's very interesting because it's a very elaborate system just to learn stupid little things like love, friendship, obstacles, confrontations with people. Huh?
Physics. I mean, look at what you've had to go through to have a model of what it is you're really experiencing here as an avatar.
And then you forget everything when you're born for a start. So you've got to relearn everything and refigure everything out. It's an elaborate system, but we do learn, we go through emotions. Emotions very important, It could be the driver of, well, according to Seth anyway, that, reality builds reality, all the emotions. If you're positive thinking, positive things will happen. If you're thinking negative, you will attract the same thing. And it's very interesting when it comes to a point of view of physics, because molecules are like that. They don't attract, That's what we call the positively charged, negatively charged particles. They're not really like that. It's just that they attract each other depending on surplus or depletion of electrons. So, life is like that too. It's very mathematical if you want. So, there are very interesting areas of exploration here that I'm exploring in my book. But that Mark can give us the basis for in his book.
I've kept you on now. We're almost a couple hours in this thing. Is there anything else that you want to talk about? Because I want to give you free reign to talk about it. Anything from your book that you want to talk about, or any other issues relative to the questions that I posed to you? And I know there were some that I delved over to the Emerald Tablets that you weren't fully up with. That's fine, and I won't dwell on that. So, but is there anything else that you want to say about the new physics and where it's taken humanity? What you see that your book is going to do for the community?
There is one thing, yes, because I've identified 4 types of expansion of matter that explains the theory of everything I'm talking about. The first one was perhaps that it's a psychological reality that we build, each of us, very quickly, very fast. Mm-hmm. Perhaps in a phi number kind of thing is created now from the pineal gland, I think. So that's one. Then the second one is Mark McCutcheon, which is the expansion of matter, to explain gravity and everything. And then the fourth one was the fact that the atoms and molecules can go larger, expand, and create other reality, physical reality that we can't see or interact with, and so creating dimensions. But the third type of expansion is my new theory. It replaces actually special relativity. It's actually a theory of motion of matter. If reality is a virtual reality or a psychological reality, you know, maybe reality isn't exactly as we think it is. When a planet comes towards us in space, it may not be moving. It may just be getting bigger. It might just be expanding. And when it moves away from us, it might just be shrinking away from us. So it's possible that not only there is no time in the atomic expansion theory, but there is no space either in my theory. And everything is here, but we see it bigger or smaller. And if you look at a virtual computer, reality on a computer or simulation, it's exactly that. You know, if a sun gets bigger behind you for whatever reason, is approaching you, it just gets bigger. It's not actually, you know, moving in the distance. So that's a very interesting, and this kind of way of explaining, you know, movement, motion, you know, in expansion theory, you know, if you bring it to another level, is another type of expansion and reduction of matter to explain why objects approach you or go away from you. And that's very interesting, because then we can go anywhere in the universe instantly, because we just have to shrink ourselves to where we want to go. Or, you know, and from their point of view, you will basically get larger to where you are. So there is still a relativity of motion. Like, as according to Mark McCutcheon, the relativity of Galileo would be more suitable than obviously the one of Einstein, which is special relativity. But mine one, I call universal relativity. I might change the name, but you know, it's a very interesting concept. So if you want to actually shrink yourself, or to move to the other side of the galaxy, if you wanted to, it may be just a question of finding the exact vibrational rate of that moment in time or space, you know, of your frequency of the matter, and you might go there instantly, because you would shrink or you would expand to that point. And that's very interesting too, because it could also explain how we can travel in time, because you know, the Earth is constantly expanding, and in its expansion, you know, although that might be unseen, there is a corresponding frequencies of matter that goes with it. And then so constantly the frequencies of all the matter on Earth is going up and up and up and up and up. So if you wanted to go, and every time it's like a new dimension, because the size of everything has changed, you see, exactly like the molecules or the spacing between them and the atoms. So if you wanted to travel in the past, you could just have, again, to adjust your frequency of our vibrational rate to the moment in the past that, and then you will go straight there, you see? So that's, I think there's maybe a lot of the alien technology that works like that. And so that's why. And also, I have to say that in Einstein, there was the relativity of time, which now is gone because there's no more space-time in atomic expansion theory. But like the fly that I mentioned earlier, although the time still take at the same rate, for the fly, they can do 4 times more than us in the same amount of time. Now that's
instead of relativity in motion, you're talking about relativity in frequency of the animation of the avatar, which creates a different perspective.
So if you were on a spaceship, for example, an alien spaceship, time might be very different. You know, for 2 hours here, they may experience a whole year, because it's not that the time ticks at a different rate. It's just that they vibrate so fast, they've got the time to do all this while we will do this. Like a fly has got the time to move before we can kill it. So there is maybe another way of saying that times can tick differently, although it doesn't really exist, but they can just do more in the same amount of time. So all of this is in my book, you know, New Age Physics, Theory of Everything, and I'm still working on it, so it's not finished yet. And it can be downloaded from the Facebook page of the Final Theory, where you found me. So if people do stuff on Facebook, Final Theory, it will probably be able, there's a link somewhere to the draft of that book. And so, and I welcome contribution, because, you know, I could be wrong on lots of things. You know, I'm just basically playing with all these concepts until we can explain everything. You know.
Right. I could come up with 1,000,000 more questions, and we could talk for weeks. I can tell with you. So I'm not going to do that to you today, and I've taken probably 2 hours of your time today. But I do have a lot more stuff that I'd like to talk with you. Maybe we can do it more another time.
And this was about, yeah.
Especially as it has to do with personal experience with gravity, energy, transformation, and your perception of the hologram. I think that's really neat stuff too, because you got a lot going on there.
Yes.
So tell us your Facebook/website, how people can get in touch with you, and any last thing you want to say. Then I think I'm going to let you go so you can enjoy that lovely London weather, right?
Yes, well, it's snowing here all across Europe for the last few days. They say that at the North Pole it's actually very warm, and that's why it's very cold here. It's snowing
no.
like crazy in March, you know. So I just wanted to say that my website is themarginal.com, themarginal.com. Or my name, Roland Michel Tremblay. There's a lot of stuff online, but there is a Facebook page. I'm on Facebook as well, but my book is not on my website, but it is on the Marginal. The Final Theory Facebook page.
Right. That's actually how I found you. I was looking for the author of that, and I saw this. Like, wow, this guy's really, really into this theory. I wonder if there's anyone else. No, it looks like just him. So.
Yes, and I've got to make sure that I made a distinction between my theories and Mark McCutcheon, because Mark McCutcheon is.
I think you did. I think you did.
He's very straightforward, and he's really into physics. You know, he's like a real physicist that, you know, has got his theory, and it all works out. I'm the crazy one who takes all these concepts and takes it further.
Well, that's okay. You know, a lot of times being in academia, you're constrained to have to do that, to operate within the confines that they put you in. And if that's what he's done a great job.
Yes, it's very amazing.
And I very much look forward.
I think he's a genius. I think that.
When's your book coming out? When are you going to write this? When's this book going to be done?
I have to finish it, but I'm going to work on it much more seriously now. So fairly soon, I hope it will probably be available on Amazon websites, or, you know, iTunes, something, places like that.
Right.
But hopefully, when it comes out, you know, people will see it, because there's a lot of potential here to understand finally what all this new age spiritual things that people are saying about and trying to explain. Finally, bring that back to a level of physics that exists, that can be explained, and from there we can probably develop a lot of technology that will give us access to these worlds. You know, and at that point.
I think it's revolutionary, and I think ultimately the truth always wins, and you can stomp it down for a while. But I really think this is as close as anything I've ever seen to being the truth.
Yes, and then finally we might have the exact same technology that the alien seems to have, and so then we'll be ready. You know, we can join them.
Well, before we do that, you probably have some stuff to take care of in London before you run off and check out of the planet, okay? But I want to thank you for taking the time to, I mean, my God, this last week of communications with you has been heavy duty, and I've been doing a lot of modeling in my mind so that I felt like we could be ready to talk about it.
Well, feel free to continue to contact me. I think it's very important that anyone who wants to find out about atomic expansion theory, I think it's very important I take the time to explain it to them. It's because every single person is very important at this point, because, you know, it's still unknown, and it's got to reach out, you know, because I think that's the truth about our physics, and I think that's about time people actually, you know, work on the real physics instead of wasting their time on theories that are clearly not correct. You know, and, you know, it's a lot of money wasted and lots of resources. And the only thing that they can achieve is to finally disprove their own theories and go to search for another, but they don't seem to be willing to read any new theories out there. So to reach them somehow, it's going to be difficult. It's a challenge, but I'm sure eventually we'll probably succeed.
Well, Roland, thank you so much for being with me. This has been Gerald Clark with 7 Planet Broadcasting, and we're going to probably do more shows, and we'll catch up with you next time.
Well, no problem. Thank you very much. Okay. Bye.
I put us on pause here.